Service or repair on an air conditioning system, check with your local authorities as to any licensing requirements needed. Some refrigerants are controlled substances. Follow all guidelines set by these governing bodies. There are many different symptoms that can cause an air conditioning system to underperform. Using a manifold gauge set to diagnose the fault can be relatively easy. Typical pressure values on an R134A air conditioning system with the vehicle not running should be between 5 and 700 kPa on both high and low pressure gauges. These values would be seen if the ambient air temperature is around 25 degrees Celsius. An increase or decrease in ambient temperature will likewise affect these pressures. A higher temperature means a higher pressure, while a lower temperature will equal a lower pressure. Always start by checking for compressor clutch cycling. This confirms there is current supply to the field coil. The low side gauge should drop to around 200 kPa and the high side should increase to around 1200 kPa. Again, changes in ambient air temperature will affect these pressure values. During a performance test, centre vent temperatures on a 25-degree day should drop to around 5 degrees Celsius. When performing diagnosis on an air conditioning system, it should be noted that many symptoms will be common. Isolating the cause requires the ability to interpret manifold gauge pressure readings accurately and efficiently. In this training module, we're going to have a look at the most common faults and their associated symptoms. If the centre vent discharge temperature is higher than normal, observe the manifold gauge set. A high reading on both gauges, but with no fluctuation of the low side gauge when the compressor cycles, indicates that there may be a large amount of air and moisture in the system. This may be caused by a leaking component or a substandard previous repair. If the discharge vent temperature is warm and the compressor is making abnormal noise, monitor the gauge set. If the high side gauge is displaying low pressure and the low side shows high pressure, there may be an internal failure of the compressor, a blockage in the compressor suction hose, or a blocked accumulator in a fixed orifice system. If the low side gauge displays low to vacuum and the high side gauge is also very low, inspect for frost build-up on the low pressure pipes. A blocked orifice tube filter screen would be the most likely cause. If the customer complains of inconsistent vent temperatures with little airflow, inspect the low side hoses for ice build-up. This would be accompanied by both pressure gauges displaying values higher than normal. This may be caused by a jammed thermal expansion valve, flooding the evaporator with refrigerant, or by an incorrectly positioned evaporator sensing bulb or thermistor. If the expansion valve is stuck closed, there will be insufficient refrigerant flow through the evaporator and suction side of the system. The corresponding pressure gauge readings will be significantly lower than normal. This may be accompanied by frosting of the TX valve. The sticking valve may be caused by moisture entry causing rust formations, an incorrectly positioned or faulty evaporator thermistor. If the pressure gauge value is much higher than normal on the high side, but normal on the low side, there may be several possible faults. These may be accompanied by frequent compressor clutch cycling and very hot high side pipes. The first thing to look for is a lack of airflow across the condenser. This may be caused by an obstruction in front of the bumper, a blocked condenser, inoperative cooling fans or slipping belt, missing foam seals between the condenser and radiator, or even an overheating cooling system. If the centre vent temperature starts very cold to icy and then drifts to warm with a reduction in flow, evaporator freezing may be the cause. Both pressure gauges will appear to be operating in their normal range. This may be associated with fast compressor cycling. A fault within the evaporator thermistor circuit or the location of the thermistor is the most likely cause. With both gauges lower than normal, warm centre vent temperature and complaints of hissing sounds from behind the dash panel, a low refrigerant charge may be the cause. Confirm the compressor is cycling and perform leak diagnosis before recharging the system. If both pressure gauges are lower than normal and there is evidence of sweating or moisture build-up on the high side pipes, the discharge vent temperature is cool but not cold, a high side restriction may be the cause. The compressor may be noisy and cycle faster than normal. This is a result of increased system pressure. You may see condensation forming on one point of the high side pressure pipe. This indicates that the restriction is located before the condensation. The condensation forms due to the pressure differential across the restriction. A great diagnostic aid used in conventional air conditioning system is the touch test. By simply touching the pipes and components, we can get an indication of any blockages or restrictions within the system. By now we know that anything in the air conditioning high side will be relatively hot, while the low side should range from cool to cold. The temperature of the refrigerant will increase before a restriction due to the increased pressure. After the restriction, the temperature will be much lower than expected due to the decreased pressure. It's essential in today's fast-paced workshop to use a manifold gauge set when diagnosing air conditioning faults. Employed correctly will save you time and money. Thanks for watching.